Hello friends, welcome to the next session on 3-inch circular arch. Today we will take up a numerical example. Let us note down the problem. A 3-inch segmental or circular, both mean the same. A 3-inch segmental arch of span 10 meters and rise 2.5 meters supports a point load of 100 kilonewtons at left quarter span. So let this be the arch. Let this be point A, B, C. Let this be the overall span. Reaction at A, VA. This is point B, point C. Reaction at B, VB. The span is given as 10 meters. So this half this span L by 2 is equal to 5 meters. L by 2 is equal to 5 meters. And rise of 2.5 meters. H is equal to 2.5 meters. It carries a UDL of 20 kilonewtons per meter over right half span. Right half means from C to B. And a concentrated load of 100 kilonewtons at left quarter span. Quarter means 1 by 4th. So this is 100 kilonewtons. I'll give the names. Let this be point D. Left quarter span means L by 4, that is 2.5 meters. Let this vertical distance be YD. Similarly, let its midpoint be point E. Let that vertical distance be YE. Since this is at half the half span, means quarter span, this whole is 5 meters. Its half will be 2.5. Now we'll start with the solution. Step 1. Reactions. So first I can write summation of vertical forces is 0. Upward forces are positive, downward forces are negative. VA plus VB minus 100 minus 25 into 5, load into span, minus 100 minus 20 into 5 is equal to 0, or same I can write VA plus VB is equal to 200. Let that be equation 1. Summation of moments about B is equal to 0. Let me start summation of moments about B is equal to 0. So loads that are coming into consideration are VA, this point load, and this UDL. So I will start. Clockwise moments are positive. So VA into 10, VA into perpendicular distance 10. This 100 it produces anti-clockwise. So minus 100 into perpendicular distance between this point and point B, because I am taking moments about point B, this distance. So from here to here this is 5. From here to here this is 5 meters. This is 2.5. So this remaining is 2.5. So this distance is 2.5 plus 5, 7.5 minus 100 into 7.5. Let us come to the UDL. Again UDL it produces anti-clockwise, so negative, minus load. Load is 20, span is 5, its CG distance is 5 by 2 is equal to 0. Hence I get the value VA is equal to 100 kilonewtons. substitute in 1, I get VB is equal to 100 kilonewtons. Now let me take summation of moments about C is equal to 0. Again same clockwise positive. When I am taking moments about C, consider the part of the arch between B and C. Forget this part. Consider all the loads between B and C. Let this be H, horizontal component H. Let's start from B, come towards C. First load VB, clockwise is positive, anti-clockwise is negative. So minus VB into perpendicular distance is 5. Come to H. Again this produces clockwise moment at C. So H into perpendicular distance between H and point C is from here to here, this distance. And that is nothing but rise H is equal to 2.5. So minus H into 2.5, sorry, plus H into 2.5 plus this UDL, load into span into CG. So CG is measured from point C, plus 20 into 5 into 5 by 2 is equal to 0. Substitute value of VB, I get H is equal to 100 kilonewtons. Step 2. Radius and rise equation. So I have the equation R is equal to L square plus 4 H square divided by 8H. So this is the equation for generalized equation for circular arch. So for the given problem, L is 10 meters, rise H is 2.5. So substitute all the values. R is equal to 10 square plus 4 into 2.5 square divided by 8 into 2.5. R is equal to 6.25 meters. This is the radius of the circular arch. Now we will form the rise equation. From derivation we know that R square is equal to X square plus into bracket R minus H plus Y bracket square. So always remember here R is radius of the curve, radius of the circular arch, H is rise, Y is vertical distance of the point under consideration, and X is always measured from crown. X is the horizontal distance measured from the crown. Now let me substitute all the values. So R is 6.25 is equal to X is unknown, keep as it is, plus 6.25 minus 2.5 plus Y bracket square. So 6.25 square is 39.06 is equal to, it is x square plus 3.75 plus Y bracket square. Taking, or I will shift this x square to LHS. 39.06 minus x square is equal to 3.75 plus Y bracket square. Taking under root on both sides, square root of 39.06 minus x square is equal to 3.75 plus Y, or I can write Y is equal to under root 39.06 minus x square minus 3.75. This is my rise equation. So I will start solving using these equations. Now let us start with bending moments. Step 3, bending moment diagrams. So we know moment at A, hinge at A, moment at B, moment at C is equal to 0. Next, let us find out moment at D. To find moment at D, let us look at the diagram. When I am going to find moment at D, forget this part of the arch. Consider only the arch between A and D. So loads acting here on left hand side. This is my sign convention. On left hand side clockwise is positive. So VA into perpendicular distance 2.5 minus H into YD. This is the perpendicular distance, and I need to find YD by using Rice equation. So I will write that equation. Moment at D is equal to VA into 2.5 minus H into YD. We have Rice equation. Y is equal to under root 39.06 minus x square minus 3.75. Substitute x is equal to 2.5 meters from crown. You have to be always careful about this x distance. Whatever the x distance you have to substitute, you have to measure this from crown, horizontal distance from crown. So substituting x is equal to 2.5, I get YD is equal to 1.978 meters. Therefore, moment at D, MD is equal to 100 into 2.5 minus 100 into 1.978. So moment at D, MD is equal to 52.2 kilonewton meters. Similarly, moment at E is moment at midspan of UDL. So that equation I will write. Now consider this be the UDL. I am going to find out at the center, at the midspan. Let that be point E. So I want to find out what is moment at E. So when I want to find moment at D, I will consider part of the arch between only this much. Forget this part of the arch. So moment at E, ME is on the right side. This is my sign convention. Anti-clockwise is positive. So VB into perpendicular distance y 2.5 minus H into perpendicular distance YE. Next, you have to consider this part of the UDL. UDL between from here till here. That is 2.5. Load into span into CG. So I will write that equation here. So moment at E is equal to VB into 2.5 minus H into YE minus load into span into CG distance. We have generalized Rice equation. Y is equal to 39.06 minus x square minus 3.75. Substitute y is equal to 2.5 meters. Sorry, x is equal to 2.5 meters from crown. Just understand the things. This point E, this is the x distance. Always this x distance has to be measured from crown, from center point. Substitute x is equal to 2.5. I get y is equal to 1.978 meters YE. So substitute all the values to get value of ME. So ME is equal to 100 into 2.5 minus 100 into 1.978 minus 20 into 2.5 into 2.5 divided by 2. So I get the value ME is equal to minus 10.30 kilonewton meters. Now let me plot that bending moment diagram. Let this be the arch. Five meters, point D, point E. So distance of point D is 2.5 and this is 2.5. At point D, bending moment value is 52.2. At point E, bending moment value is minus 10.3. Since on left hand side it is point load, join them by straight line. On RHS it is UDL. Its value is 52.2, 10.3. Now next step, NT and RS at right quarter span, means right L by 4 distance from right side. So for that let me draw another arch. Let this be the rise, this be the origin. This is the quarter span point. Quarter span means L by 4. L by 4 from the center. This whole distance is L. L is equal to 10 meters. This distance is L by 2 is equal to 5 meters. Quarter span means L by 4 from here, 2.5. Consider this triangle. This distance is R. Let this angle be theta. Now at point, say point F, horizontal reaction H is 100 kilonewtons. Same, because there are no horizontal forces. Shear force at this point, So shear point at this point is VB minus 20 into 2.5. Consider this part. I am going to find quarter span here at this point. So net shear force at this point is summation of upward forces. Upward is positive, VA minus 20 load into this span 2.5. So I will get the value 100 minus 50. V is equal to 50 kilonewtons. Now I have to find theta. For this theta, I can write the equation sin theta is equal to OYH, opposite side y, hypotenuse, 2.5 divided by R. So sin theta is equal to 2.5 divided by R is equal to 2.5 divided by 6.25. So I get the value theta is equal to 23.58 degrees. Now calculate NT and RS. NT is H cos theta plus V sin theta. I think you will get the answer 71.65. RS is H sin theta minus V cos theta. You will get the answer 85.82 kilonewtons. So this completes the problem. Thank you.